Okay, this is a little quick lesson on counting atoms. You have to be able to correctly count atoms before you can balance equations. So before we get into balancing equations, we're going to learn how to make sure we know how to count individual atoms in the molecule of anything. All right, it's real simple, so watch carefully. Let's start out easy. If I have H2O, all right, I have hydrogen, all right, and oxygen, makes up water, all right? And let's say I want to count how many individual atoms there are, all right? The subscript tells you how many atoms, right? So there's 2 hydrogens, and then if there's nothing written here, it's understood to be a 1, so it's 1 oxygen. So that's pretty straightforward and easy. So for every hydrogen or every water molecule, you have 2 hydrogens and 1 oxygen. All right, out to the left, all right, this would be a coefficient. We call this number a coefficient. All right, and coefficients tell you the number of molecules. So in this case, since there's nothing written, it's understood again to be a number 1, right? So it's 1 molecule of water, which contains 2 atoms of hydrogen, 1 atom of oxygen. All right, what if you had 5 molecules of water? 5 H2O. All right, break it down. Hydrogen, oxygen. All right, here's what you have to always remember to do. You have to distribute the coefficient to every subscript. All right, so if I say 5 times 2, I have this time I got 10 hydrogens. And then if I say 5 times 1, because it's understood to be a 1, nothing's written there, I see 1 oxygen. All right, so in this case, I have 5 atoms of oxygen. So the big thing is just always remember to distribute. All right. Now let's try one that has a polyatomic ion in it. Let's say if we had 3 molecules of aluminum sulfate. So this is 3 molecules of aluminum sulfate. All right. If I break it down, I have aluminum, sulfur, and oxygen. All right. So 3 times 2 is 6. So I would have 6 individual atoms of aluminum here. All right. What about the sulfur? I have 3 times 3. 3 times 3. So 3 molecules, and you got to distribute that 3. So 3 times 3 is 9 atoms. Just remember, anything on the outside goes to both of those elements, right? And then to get how many oxygens, I have to say 3 coefficient. Don't forget the coefficient. 3 times 4 times 3. 3 times 4 is 12, times 3 would be 36.
Wait, so you're saying we'll be multiplying with the coefficient on the inside first, then on the outside?
Either way, it doesn't really matter. As long as you account for the coefficient. One of the students had a question, so you're saying you're going to multiply the number on the inside first. It doesn't matter. If I say 3 times 4, or 3 times 4 times 3, it would work the same. All right, just as long as you distribute. So always distribute. All right, let's do another one. All right, let's say if I had 3 NH4 all right, so this would be called ammonium carbonate. Ammonium is a polyatomic ion, ammonium. All right, I want to know how many individual atoms of each element. All right, so this time we got 4 different elements. So for nitrogen, I'd say 3 times 2, which is 6. 6 atoms of nitrogen. All right, and then for hydrogen, I'd say 3 times 4, but there's also a 2 out there, so 3 times 4 is 12, times 2 is 24. Okay. Carbon. 3, and there's nothing there, so it's understood to be a 1, because that 3 goes with oxygen, not with carbon. So 3 times 1 is just 3. And then oxygen, 3 times 9, or 3 times 3, excuse me, is 9. 9 atoms. So just double check, always double check your work. 3 times 2 is 6 for nitrogen. 3 times 4 times 2 is 24 for hydrogen. Carbon is 3 times 1 is 3. Oxygen is 3 times 3 is 9. So that's how you do an atom count for any molecule.